next we will be looking into the closure algorithm. So, for this LR1 items, the closure algorithm will be similar to what we have the closure algorithm for this LRJ SLR parsing. So, here but only thing is that these items have got this additional part. So, it has got this look ahead token part. So, this look ahead tokens will also appear in the closure set. So, for an item I, so if we are trying to get a closure, so for I we are trying to get a closure, we initialize this set j to I, and for each item A producing alpha dot B beta semicolon A in j in so this should be in I, this is not in j, in I. So, we have to see whether there is a grammar rule which has got the form B producing gamma. So, if there is a rule like B producing gamma, then each terminal, for each terminal B in the first of beta A. So, so when should we go by this rule? When should we go by this rule? So, this go to B. So, this go to B we will see, we will like to see if we see that there is something starting with beta followed by A. So, if there is something like that, then only we will be using that particular transition in the parser. So, that is what is done here. So, for every production rule, so which is of the form B producing gamma, then will be so for each then for each terminal B in the first of beta A. So, we are doing this B producing dot gamma semicolon B, it is not in J, it is not yet added into the set J. So, we add this B producing dot gamma B to semicolon B to J. So, that way it is just otherwise it is same, only thing is that so previously we did not, for the LR0 item we did not have look ahead. So, there was this part was absent. So, this part was absent. So, we were just doing it like this, for each production B producing gamma of J, we were adding this B producing dot gamma into J. So, that is what we were doing, but now I have to tell what is the look ahead part also. So, just to do that, so the look ahead part is decided by this, by you compute the first of beta A, and whatever symbols are coming in the first of beta A. So, we have to add this thing into this set J. So, this way the process will continue till no more items can be added to J, then we will be returning J. So, that is the closure computation algorithm. So, we can use this for getting the closure of items, and then we can see the go to part. So, go to part is also similar. So, there is initially, so we are trying to find this go to of I x. So, I is an set of items and x is the grammar symbol, then goes initially j is made equal to empty. Then if there is an item like A producing alpha dot x beta semicolon A in I, then we take the closure of A producing alpha x dot beta semicolon A, and then we add that item to J. So, this way we take the closure and add all those items to J, and then it will be returning J. So, this way we can constitute the closure set, the go to part for the this LR1 items. Next we will see how to construct the LR1 parsing table. So, for constructing LR1 parsing table, so the policy is same as we have done in LR0 parsing table. So, we first construct the collection of LR1 items C, which is I0, I1 up to In, and for the augmented grammar G dash, and then state I is constructed from this item II like this. So, if A producing alpha dot A beta comma semicolon B is in the set II, and go to II A is I j, then action I A is said to be equal to shift j. So, this part there is no change. So, this is exactly same as what we have for the LR0 parser, okay, the SLR parser. But this one it says that if you have got a rule like A producing alpha dot semicolon A is in II, then set action I A to reduce by A producing alpha. So, here you note that we are not looking into the follow set of A. So, follow set of A, whether it can contain small a or not, etcetera, those things are need not be computed. Definitely the follow set will, if it is a valid thing, then the follow of A will contain small a. If my string is valid, then the follow of capital A will definitely contain small a. That is why after doing this reduction, because the string was something like this. So, this part was alpha and then one look ahead token was A, okay. And we said that we will reduce by this whole thing by A. That means, in some sentential form this small a will appear after capital A. So, small a is definitely there in the follow set of A, but if maybe some symbols for some cases it will be something different. So, we will be doing this reduction only when we are getting this I A. So, in case of LR0 parser, so this reduction rule was put for all the symbols which are in follow of A, follow of capital A, but in this LR1 parser, so we are adding this rule only to the case where the input symbol is small a. And then S dash producing S dot semicolon dollar. So, if it is there in some set of item, then we set this action I dollar to accept. So, this is the this is the simple way. So, of this it is same as that SLR parsing, and if there is any conflict that appears, then we say that the grammar is not, it is not SLR. So, this is not LR1. So, the S should not be there. So, if there is any conflict, even after doing this, if there is a conflict, then the grammar is not LR1 grammar. So, but unfortunately we do not know grammars which are parsers which are more powerful than this the canonical LR parser. So, if this thing fails, that means you really need to work with your grammar and try to do something or bring some context sensitivity into the parsing process. So, you by means of context free grammar, so you will not be able to generate a parser for the particular language. So, we will see that if you look into this parser generator tool Yak, then Yak, Bison, etcetera. So, those tools, so they apart from this LALR or LR1 parsing table generation, so they also allow several context dependent features, and those context dependent features may be used for resolving the conflicts that are occurring in an LR1 parser. But anyway, for the time being, we assume that once we have come to this LR1 parser, since it is very powerful, so it will be able to resolve whatever constructs we have in our programming language. And then the go to part is same as what we have in LR0 parser. So, if go to IIA is equal to ij, then we set this go to IA equal to j, and all other entries which are not defined, so they will be marked as error, and initial state of the parser is the one that is constructed from this one, S dash producing dot S semicolon dollar. So, this dollar is the end of string character, or the so then this is previously in case of LR0 parsing table construction. So, we took the item S dash producing dot S and we took the closure of that, but here I have to tell the look ahead token also. So, here the look ahead token is dollar. So, that is the additional thing that we have. So, this way we can have this LR1 parsing table constructed, and we can have, otherwise the parsing algorithm is same. So, that is same what we have in the LR the parsing one. So, let us take an example. Suppose we have got a set of grammar rules like this. So, this goal producing expression, expression producing term plus expression, expression producing term, and then this term producing expression factor star term, term producing factor, factor star id. So, this is the grammar G, and we have added this additional rule goal producing expression to make the grammar G dash, the augmented grammar G dash. Now, I said that the first rule, the first state or the first set of item I0 is the closure of this goal producing dot expression and the symbol the look ahead token is dollar. So, I am expecting a string, I am expecting to see a string expression and that will be followed by dollar. So, that the next input symbol will be dollar. So, that way this is done and then you have to take the closure of that. So, this dot expression is there. So, expression producing dot term plus expression. So, this will be created, this dollar is carried forward, then this expression producing dot term is taken. So, this dollar is carried forward, term producing, now expression producing dot term is there. So, based on that this term producing dot factor start term but here now this if you look into this this one, this expression producing dot term factor dot term comma dollar, then this from this dot term you will see that it will be producing dot factor start term and then from this dot factor it will be giving me this, also it will be giving me a term producing factor and then this term producing dot factor and then this expression producing term. So, this will be giving me expression producing dot term. So, this one will come and many of these symbols like plus and dollar. So, they will come both of them will come because another item will be created where this plus will also be coming because their core part will become same, that way it will come. Similarly, from I1, so this is goal producing expression dot will come, from I2 it will be expression producing term dot and then so from this rule expression producing dot term dollar. So, it will giving me expression producing term dot and this expression it will give me from this this item. So, it will give me expression producing term dot plus expression dollar. So, this way these items, the LR1 items will be constructed for this particular grammar. Next, once these items have been constructed, so we can construct the corresponding table. So, it corresponding automata will be like this. So, S0, S1, S2. So, these are the various states and then based on this rule that we have seen previously, that parsing table construction rule. So, we can construct this table. So, this way, so for from state 0, so on ID, so it is so it is going to state it is on ID it is coming to state 4. So, this is that ID it is state for shift 4 and then on this term factor and expression. So, it is going to the states 1, 2 and 3. So, accordingly this go to part is put like this. So, this way we can construct this table. So, this table construction is same as what we have in the previous case, like this the SLR parsing table, for that how whatever way it is constructed. So, that they will be coming like that. So, once this is done, so we can this table is ready, but you see that the number of states will be much more compared to this LR0 parser or SLR parser. Of course, for this particular case we do not have much number of states, but it may so happen in many cases that number of states are much higher. So, this is LALR parsing algorithm. So, that is also doing a look ahead by one token. So, they are called LR1, they are basically LR1 parsing, but with look ahead, they are called look ahead LR, that is why it is called LALR. It reduces number of states in an LR1 parser and by merging states that differ only in the look ahead sets. So, if there are a number of states that they differ only in the look ahead sets, then it will merge all those states together and call them as one state. So, as a result, this SLR and LALR tables they will have the same number of states, though we are not proving this result formally. So, it can be shown that this SLR and LALR parsers they will have more number of states, whereas the LR1 parser will may have large number of states. So, for a C like language, so there are several hundred states in the SLR and LALR parsers, whereas for LR1 parser, so it may be one order of magnitude more. So, several thousand states may be there in the LR1 parser. So, this way we can have we can have this thing, we can have this LR1 parsers converted to LA-LR parser. So, we will see how to do that, so that the number of states are reduced. Okay. So, next we will see how an example of how to do this thing. So, first of all, suppose this is the grammar that we have, and for this grammar S dash producing S. So, this is the new rule that is added, and this S producing C C and C producing small c, capital C and D. So, this small c and small c and small d. So, these are the terminal symbols of the grammar, and rest are all non-terminal. So, the set I 0 is constructed by which we are for which we are doing this thing. So, this we take this production S dash producing this item S dash producing dot S and dollar, and then we have to take the closure of that. So, closure of that gives me S producing dot C C dollar. So, now dot C C dollar. So, what I have to do is for taking the closure of this item. So, I have to consider the first set of. So, you remember that if I have got a production like x producing dot x dot y z semicolon alpha, then what I have to do is I have to take the set first y z alpha, and then I have to see what is coming there. So, for them the this has this look ahead token, I have to do it like this. So, if I have got a production rule like y producing gamma, then for that I have to see what is the first set of this y z alpha, and accordingly I have to see I have to add them to the first to this item. So, here also, so this dot C C, and there is a rule like C producing C C. So, when I am trying to use this rule, so I have to see what can be derived. So, what is the first set of this capital C. So, this first set of capital C contains this small c and small d. So, they are added. So, I have to see what is there in the first of this C dollar, and this first of C dollar, capital C dollar will have small c and small d. So, this is the item that is created. Similarly, by this rule it will be C producing, so I am looking into the C producing D, but I have to see like what are the first of this C dollar, and the first of C dollar again having C and small c and small d. So, they are added to the look ahead token. In this way, these look ahead tokens are calculated. So, this is a bit cumbersome, but that is the technique. Okay. So, we have to do it like this. So, you see for this small grammar having only say 3 grammar rules, S producing C C, C producing small c, capital C and or D. So, the 3 grammar rules. So, there are 10 states that are created, that way it is a large number of states that have been created. Now, what we look into this for converting it to LA-LR, consider the states I 4 and I 7. So, I 4 and I 7. So, you see that there the core part is same, this is also C producing D dot, this is also C producing D dot. So, what is differing is only the look ahead part. So, here the look ahead part is C D, here the look ahead part is dollar. So, we will be combining them together and call them a new state I 4 7, and this has got C producing D dot semicolons, that look aheads we will have look aheads of both the states C D and dollar. So, C D and dollar they have been taken into consideration. Then the I third, then this 3 and 6. So, 3 and 6. So, this is 3 and this is 6. So, here also the look aheads are this core part is same. So, it has got core like C producing small c dot capital C. So, this is matching, then C producing dot C capital C, this is matching, C producing dot D. So, this is also matching. So, again what is differing are the look ahead tokens. So, these look ahead tokens, so they will be merged together and we will be getting this state I 36 and this 8 and 9. So, here also this 8 and 9, so they are matching. So, their core part is matching. So, we just merge them together. So, essentially from this 1, 2, 3, 4, 5, 6 states, so we could reduce them to 3 states. So, total originally there were 10 states, and now from the 6 states, so 10 minus 6 4 and 3 new states created. So, total number of states turns out to be 7. So, if we construct the SLR parsing table, then you can check that this also gives rise to 7 states. So, that way this is going to be this LALR parsing. So, this is going to help us. Of course, it is cumbersome in the sense that we are the way that we have done it, we have first produced the LR1 items. So, and then we are trying to see whether there is any merging possibility between the items. So, that way the constructing the LR1 items itself is costly, and then if you then checking for the merging and all. So, that is why this LALR parser construction is going to be a costly affair, though automation is no problem. So, automation can be done. So, rules are well defined. So, you can do the automation very easily. So, what can be the other way of constructing the LALR parser? So, this is known as step by step approach for this LALR parsing table item construction. So, sets of states constructed as in LR1 method only. However, so we do not construct the entire LR1 set of items and then try to do the reduction, then try to merge the items. Instead of that, at each point whenever a new set is spawned, so we see that whether it can be merged with an existing set or not. So, in the previous example you see that when we have when we had generated this say for example, this state numbers this particular state 7. So, whenever we are generating this 7, so whenever this is generated we see that okay, it is matching with 4. So, we do not generate a new item or new set 7, rather we add this dollar to this set. So, that way it is going to be done. So, it will not generate large number of new states. So, number of states generated will remain same as the SLR parsing. So, so that is how this parsing table for LALR this set of items for LALR parser will be created, that at each point when a new set will be spawned. So, we will see whether it can be merged with an existing set or not. Whenever a new state S is created, all other states are checked to see if one with the same core exists, and if it is not, if there is no such thing exists, then S will be kept. Otherwise, it is merged with the existing set T, and we name the core as with the same core to form the state ST. So, previously you have seen that we have named the states as 47, 47, I4 and I7 were merged. So, we told the item to be I47. So, similarly, this 3 and 6 was merged. So, we called it I36 or I36 like that. So, that way this merging is done, and after doing the merging, so we can get the after doing the merging we get the new set of states, and the new set of states will be number of states will be same as the SLR number of states. So, this way we can step by step we can construct the LALR parser. So, after this, so since it is very difficult to do some exercise on this SLR and this canonical LR and LALR parsing. So, rest of our discussion we will be restricting ourselves to SLR parsers only, but whatever discussions we do with SLR parser, so they will also be valid for this canonical LR and LALR parsers. So, that strategy will remain same, only thing is that maybe for some grammar where this SLR parser is giving rise to conflicts, this canonical LR and LALR may not give you conflicts, but there may be situation where the grammar is such that it also gives conflict there. So, so in that case we have to resolve conflicts accordingly. So, how to so next important issue that we will be looking into is the usage of ambiguous grammars for this parser construction. So, ambiguous grammar means that there is ambiguity. So, like this is that famous ETF this expression grammar. Previously we had written like E producing E plus T or T, then T producing T star F or F, and F producing within bracket E or ID. So, this was the grammar. Now, what we do? we do not take this extra non-terminal symbols, this E, T, F. So, why these non-terminals T and F were introduced? They were introduced to ensure the precedence of the operators, because until and unless you have done this, until and unless you have reduced to a T, so you cannot reduce to E. But for reducing to T, so these multiplications are already taken care of. So, with this you can whenever you are doing a reduction to E, either it can be an expression that does not contain any multiplication, or it is an expression where there is a addition operation, and one part of it and the two parts of it, they can contain addition or multiplication, but at the topmost level I have got addition. So, that means the addition, it has got the lowest precedence compared to this multiplication. So, this way similarly this F is put within bracket E. So, F is F has been introduced to ensure that this parenthesis, it has got the highest precedence over any other operator. So, this way this parser, so it could generate parse trees unambiguously, but the difficulty that we face is many a times what happens is that as you are increasing your number of non-terminals in your grammar, so the parsing table becomes larger, but in particular at least the go to part of the table, that will become larger, because go to part will have one entry for each of the non-terminal in each of the states. So, that go to part is going to have problem. Like if I say that this after constructing the items, so suppose if I see that if there are say m number of items and there are 3 non-terminal symbols, so go to part will have at least m into 3 number of entries. Whereas, if somehow I can make this grammar that has got only say one non-terminal, then the table size will become m into 1. So, that way the number of entries in the table becomes small. So, the table becomes simple. So, what we do, we many times this parser, the parser generators, they say that we purposefully make the grammar ambiguous, so that the parsing table size becomes small, and then naturally once we do that, so it can give rise to conflicts. So, I can so I have to resolve these conflicts, and we resolve the conflicts in a particular fashion. So, depending on the grammar, so from the knowledge about the language for which we are designing the parser, so we can try to resolve the ambiguity by putting additional rules. Like if I substitute, if I write this particular grammar without using this extra non-terminals T and F, I always tell it is E, then we know that this addition is of lower precedence than multiplication. So, if this thing is told to the parser, so when it is generating the parse tree, so if it has got a confusion that on getting the next input symbol, the input operator plus or star, whether to shift or whether to reduce, so it can take a decision depending on what operator it has seen and what is the current situation. So, based on that it can take a decision. So, we will see that these ambiguous grammars, it can lead to conflicts, but at the same time these ambiguous grammars, so they can be used to make the parsing table small, and that helps in the overall parsing process. So, makes the parsing process faster. So, that way this sometimes we will see that we purposefully make the grammar ambiguous.